My name is Pierre Ferragu. I'm a research analyst. I run my own research boutique, Newstreet Research, and I cover technology infrastructure. And as I am an analyst, I like to share slides and show numbers and confuse people with facts that are like borderline facts. So that's what I'm going to do real quick now. So what we are talking about in the panel today is the future state of the AI infrastructure stack. And like the four simple ideas I wanted to share with you before we have this conversation is the following. I chose silly names to characterize them: a storm, a tsunami, a clash of titans, and of course, digital goods. So if we talk about the storm first, on this analysis, what you see is how the trajectory of OpenAI models is shaping up with, on your x-axis, on a log scale, the amount of compute required, and on the y-axis, the performance on the ARC benchmark that is measuring how the model is getting closer to general intelligence. And you see that you have had like a 200,000 times increase in compute between the inference of GPT-4o and the inference of o3, and that took us from scoring 5% on that benchmark to 88%. And to give you an idea, a jobber on the Flex platform scores on average 77%, below o3, and a grad student, the STEM grad student, scores 99%. We've talked a lot about DeepSeek and how they're making things more efficient. So you can see in gray the trajectory of DeepSeek. We have only the first 2 data points, but we can interpolate from that. What you see is that, yes, DeepSeek is slightly shifted to the left, so it's about 10 times more efficient at doing things similar to the early models of OpenAI, but they are on a slower slope, if anything. So they will, if they were to move towards more reasoning, they would actually be eating even more compute. On my next slide, I want to talk about the wave, the tsunami. And here, of course, I'm referring to the size of data centers. OpenAI has been kind enough to share in their roadshow some of their financial projections, and that's what I wanted to share with you today. In 2029, they plan to spend $36 billion on training compute and $24 billion on inference compute. To put things in performance, spending $24 billion in a year means you're running a $100 billion data center, and 36 billion is, of course, a $150 billion data center. So what's interesting here is that OpenAI is planning to have a brand new data center that costs $150 billion to do training and development on January 1st, 2029. And this data center is going to be deployed late into 2028. That means it's going to be a brand new data center. And if OpenAI wants to move to the next generation data center in 2030, this data center will have to get filled up with other workloads. And I think it's a very important structuring factor in the industry. Clash of titans, of course, I refer to GPUs versus ASICs. We know, thanks to Google, that ASICs can be very successful. TPU can prove to be twice better in terms of flop density as an NVIDIA GPU. It's selling for a much lower gross margin, so it can be 3 times better on a per dollar, flops per dollar. And it tends to be more efficiently used, and we get another 50% improvement. So yes, ASICs do deliver 3 to 5 times better performance, but does that mean they're really going to win that clash? And then the last one, before I welcome our panelists, is about the digital goods. So the one thing that DeepSeek, with the 2 papers they published in late January this year, really revealed is that we are actually in 2025 moving into the next era of AI development, in which humans are literally taken out of the loop, where models are being improved with reinforcement learnings on tasks that are verifiable or that are semi-verifiable, And that means there is no limit to how much you want to increase compute in order to improve the capabilities of a model. We went through that whole story already 10 years ago with AlphaGo and AlphaZero. AlphaZero applied the same technique to learning how to play chess and to play Go. And AlphaZero today plays chess and Go in a suprahuman way. So are we now setting up the infrastructure to have models that are going to be suprahuman call center operators, or maybe suprahuman quantum physicists? And that's really what the quest for the digital goods means to me. So with these 4 ideas in mind, scaling the compute is completely unleashed. The infrastructure build-out for training and development needs is gigantic. We have a question mark on whether the infrastructure is going towards ASICs or GPUs or both. And of course, the end game is probably more ambitious than we would have ever thought, with this idea of suprahuman capabilities now being just in reach. And with that, I'll welcome our panelists, and I'll move to the right. So I guess we don't need to do a round of introduction. I think we have our background on the slides. We could maybe do like a very, very quick introduction on what your companies are doing to set the background, and we'll take it from there. Rohit?
Sure. So Acceldata is, the leader in data observability. We work with some of the largest enterprises across the world, enabling people to manage their data. 2 weeks back, we just launched the agentic data management platform. As people are investing more in data and analytics and AI, everybody needs AI to now improve the quality of their data overall and make it more manageable. So that's what the company does.
Good afternoon, everyone. AMD has been around for 55 years, actually, as long as many of us in this room, and spent the better part of the past decade becoming the leading provider of data center CPUs, and then about 2 years ago has expanded to take on NVIDIA in the GPU market, and is already the #2 provider of AI computing in the world, and will continue to grow out its business to provide that full spectrum computing necessary to support this incredible wave of innovation.
Thank you, Pierre, for hosting us, and thanks, everyone. My name is Guerre, and Together AI is working to build the world's leading AI acceleration cloud. We believe the future is not one big model to rule them all, that there will be lots of leading models, and many of them will be open source. And in that world, we think a lot of the value will accrue to infrastructure. But these models are very, very expensive to build and operate. And so if we can be a leader at making that more cost efficient and performant, a lot of value can accrue to our organization. And so we built what we believe to be a leading research lab that does just that and makes these models faster to run, more cost efficient to run, and to train. And that we run that from sort of infrastructure up to the highest levels of software.
Hey everyone, I'm Raymond, founder and CEO of Unstructured. We're pretty easy. So we do ETL for generative AI. So we built a platform that makes it easy to take any unstructured data, so natural language, image, audio data that enterprises may generate, so think private internal data, and then transform it into chunked embedded JSON, and then make it available to model providers, and then to generative AI architectures. So pleasure to be with you.
Thanks, guys. So let's start with the first of our topic. So like the storm generated by reinforcement learning, increasing test time compute to increase the reasoning capabilities of the models. My question would be, maybe I'll start with you, Jamie. How do you see that? How important is it in the way you think about the future of the infrastructure of Together AI?
Yeah, it's been a tremendous shift. And really, a lot of the improvement in building these models early on was coming from pre-training, sort of taking all of the internet's data, doing long-term training on these models, and building larger and larger models with more and more data. And that's where the gains came from. Subsequently, the gains started to come from post-training and things like reinforcement learning through human feedback. But today, a lot of the gains are coming from this notion of inference time compute. And being able to teach the models to think more before responding. And this is giving tremendous gains in the accuracy of the models. And interestingly for us at Together AI, because we help organizations build on open source models, where the organization can deeply fine-tune the model, own the resulting model, control how they operate the model and where they operate the model. And the big news here, obviously, in the last couple of months has been DeepSeek. DeepSeek made improvements both at the post-training level and at the inference time level. At the post-training level, switching from human feedback to do reinforcement learning, to do verifiable tests. And so this allowed them to make tremendous gains very, very quickly, and now release a model that's sort of competing on par with a lot of the leading closed source models. And then the second is that they made a lot of improvements to the inference time compute. And this really aligns well with our business, because we've been investing and making inference faster and more efficient. And now as these models need more inference time compute, we can help make that fast and efficient. And I think the fact that you're seeing these sort of leaps and bounds happening is just symptomatic of how early we are in all of the technology. I think we're going to continue to see that. We're going to continue to see the quality of these applications and models and systems kind of going up rapidly over the coming couple of years still.
Keith, on chip design, AMD and its competitive landscape, how is this evolution affecting you?
Well, it's fantastic. It's a good thing. Inference time, desk computers, it was like an early Christmas. I mean, when you think about it, if you look at the tens to hundreds of billions that have been spent on GPU computing up to now, the majority of it has been spent towards training, right? Large-scale training clusters, and that's not going to stop. I mean, there's still going to be a need for large-scale clusters, particularly in science, right? I mean, as all the fields of science become computational in nature, and we've seen some really exciting things sort of happen this year with the Nobel Prize for AlphaFold and that kind of thing. You're going to see that across all the fields. Large-scale clusters for simulations, both on traditional HPC and AI, are going to still be very, very important. But as the market as AI becomes this widely sort of diffused technology and much more and consumed at scale, both in the enterprise and our consumer daily lives, you're going to see the actual sheer volume of computing shift more towards inference and towards the edge. And that plays well to AMD's strengths, because AMD has the widest portfolio of computing, from FPGAs to CPUs to GPUs. And ultimately, you're going to need a full spectrum of computing to deal with a full spectrum of AI use cases. It isn't going to be a one model running in one cloud with one chip. That's just not the way it's going to play out. In fact, I spent a lot of my time meeting with countries. And for those of you that know me, I played a very early role in the whole evolution of sovereign AI. And look, when countries started leaning into AI infrastructure, essentially 4 or 5 years ago, and greatly accelerated post-ChatGPT. But those conversations going back to 2020, the first question was, what is a GPU? I mean, it was pretty early days, right? Where we are today with countries, it's really about silicon diversity. It's about having a resilient AI infrastructure to deal with all these essentially unforeseen changes. And so countries are really looking to diversify, and companies are looking to maximize the TCO for these models, right? Because they're not all getting bigger, but some are getting smaller, and they're moving to our phones and our watches and so forth. So it's actually a really exciting time to be anywhere in that stack, I think, quite frankly. And there's only one direction for the growth, because I know it's been a bad couple of days in the market, but the only direction is up and to the right. There's no future scenario where there'll be fewer data centers or fewer GPUs or fewer innovators like you guys. So I think it's good for everyone.
Brian, your focus is really making data easier to digest, easier to leverage in AI. These models that are getting smarter and smarter, more and more capable of reasoning, how does that affect the way you think about data?
I think from our side, right, a lot of the value from generative AI comes from when you join private knowledge to these models or make it available to these models. And so the way that that's played out over the last couple of years has been that large organizations form, lots of dozens and dozens of different use case-based teams in order to prototype. So you had this like POC explosion. As those proof of concepts, they had more confidence in which ones were actually going to make it into production. You saw some consolidation. A lot of them realized they needed to reorganize human processes around generative AI. I think that's kind of the phase that we're in right now for at least the companies that are furthest along. And meanwhile, like the infra stack has matured, models have gotten better, but we've also realized like a lot of the challenges associated with it. So for example, for us, just to take like a PDF today, right? Like 6 months ago, we were using GPT-4o for everything, Claude 3.5, some upgrades came to that. That was much better from a vision language model perspective. Then out of nowhere, Google Gemini reduced the price by up to 95% per document. And it's almost like you have this kind of like dual world going on here. You have on the one hand these dazzling improvements that are happening on these large models. On the other hand, just doing simple things is still really hard, especially in a cost-effective way. And so to take like a single PDF and to transform it into chunked embedded JSON, right? We need an image-to-text model, a couple runs at a text-to-text model, a text-to-embedding model, and then a bunch of like glue logic throughout that, just to get that single page to a vector database or to tee it up for a training run. And so these big companies are on the one hand looking at continuous post-training or what they can do to fine-tune these large models for these incredible use cases. On the other hand, they're really grappling with, okay, how do we take all this data, make it available to these models in a cost-effective way, right, at scale, just because the scale of the data is just so immense.
And Rohit, your turf is really to make AI easy to adopt and to leverage within the enterprise. So same question to you, these models getting more and more capable of reasonings, how does that affect your role?
I think it, obviously it's a huge tailwind for our business in general because couple of things, right? There are different phases in which AI is getting adopted. And the first phase is getting your data ready for AI. And for the last couple of years, we've seen that there's been immense amount of focus on unstructured data. And in the last 3 months, we started seeing that the focus is now shifting back to structured data. And the reason is that when you actually have your facts in place, the unstructured documents, emails, everything else that you have in the rest of the enterprise, it adds context to the data that you have. So most of the enterprises who are coming to us right now, they're looking for preparedness of their data to be fed into for either post-training or in some cases, when you're using your own model or you're training your own, then for pre-training, but also for subsequent, fine-tuning for their use case specific, purpose-built, I would say, supply chain of AI. Obviously, the models are getting more and more efficient, and it's great news that disruptive innovations like DeepSeek are coming and shaking the market. I think this is not the last of the disruption that we've seen. I think models will get more and more efficient. I don't think everybody will need to load the entire model. I think partial model, you don't need the entire neural network to get your use cases. I think this is the time where this whole thing starts getting commoditized. And when something so fundamental gets commoditized like cloud or like mobile phones, the adoption curve will just take off from there.
Okay, that's great. So let's move to the second observation I made in my prepared remark, which is, even if we're all very excited about this compute growth on the inference side, like the very, very large build-outs of this world are still very much about training, and we are talking gigantic scale of compute that is going to come and become available in the market year after year, as long as the leading labs go after the frontier and push back the veil of ignorance of generative AI. And so the same question I'd like to ask to Keith and Jamie is, how confident are you about the ability of the industry to fill in these very large data centers if the leading edge research keeps moving to the next generation of data centers every year?
Yeah, so it's interesting because the chip industry used to work on this 2-year cycle, right? And just giving the market just enough time to absorb, the one generation and get ready for the next generation. And now we've moved to this annual cycle. And it's a lot. I mean, it's a lot on the companies and it's a lot on the customers. I don't know if it's going to last forever. I don't know. I mean, it's and you have to divide the computing, right, fairly into 2 parts. You've got hardware and you've got software. Hardware takes time, and there's molecules and there's physics and and ramping up manufacturing processes takes time, and you're placing bets essentially 2-3 years from now, right? You're buying wafers and cutting contracts with TSMC for where you think things will be in 2027, 2028, right? But software is 24/7, right? You are constantly updating your software, constantly innovating, constantly pushing those out, and increasingly the performance of that hardware stack is driven by software. So it's it's a little bit harder to predict exactly where the hardware is going, but we all have chip roadmaps and we all see those innovations. In fact, I just had a meeting with France's national research organization, CEA, and their LEDI, which is their semiconductor innovation group, and they were showcasing sort of to my team these technologies that are 5 years out that they hope to innovate and bring to the market in time. So there's sort of a horizon of technologies that could come and make amazing leaps in the hardware, but the software is where I think most of the performance gains are happening. And I have absolute confidence that the industry is going to keep up and exceed those expectations. At AMD, we lean on the community. We have a community-based open platform called ROCm, which is our philosophy of driving things versus a closed approach. And the community loves that. I mean, there's almost a limitless number. Every single night, 1 million models in Hugging Face get optimized on our platform. And so that is where the future is. I agree, it's going to be an open source. And so I have absolute confidence. There are still supply chain issues, and there are still supply chain vulnerabilities. The world is complex and it's dynamic, and so I think that's something we can't fully predict. But I think the amount of money pouring into this space, from energy to data centers to chip design, is on par with what the world needs.
Yeah, Jamie, let me maybe narrow the scope of the question slightly for you. You are deploying a lot of infrastructure. How do you think about these giant deployments happening next door and how it could affect your business?
Yeah, I mean, I think, again, I go back to really keeping in mind how much we're in early days. And I think, if we look at like 1999, 2000, it was crazy. Everyone thought the internet would be this huge thing, huge phenomenon. People would buy pet food on a website. People would buy books through a website and not go to a bookstore. It was insane, and it pulled back. But of course, all of that actually happened, and all of that investment just needed to kind of grow even more so, just a little bit later. I don't know that we'll have a pullback in this case. I do think that like every application, every feature of every application today has been rewritten to be internet-based, essentially. And that was inconceivable in 1999. I think that every application, every feature of every application is basically going to be rewritten to be AI-based with these generative models over the next however many years. And so I think we'll definitely fill the demand. I think that these really large infrastructure builds, we'll see. I think a lot of the really large infrastructure builds are very focused on training. You don't need all your GPUs in one data center for inference. You can spread them out to the edge, as Keith was saying. And we believe more and more of what's happened with DeepSeek is going to continue to happen. Essentially, the building of these models, achieving frontier-level quality, is going to be more and more democratized, more and more distributed, and lots of organizations will do it. Meta has their Llama conference in like a month or two, and they'll launch Llama 4. It'll probably exceed some of the current models, and more organizations will do that. As that happens, maybe there's less need for the huge pre-training data center, and more ability to do this more efficiently in more places for more organizations.
Rohit, Brian. Well, actually, Brian, let me start with you. So I hear you say a lot, it's hard, it's difficult, and I think my question to you would be, could putting AI at work, like deploying, like making these real life use cases scale out, be a limiting factor at some point in the pace at which we can grow inference volumes?
Yeah, I mean, on the conference circuit last year, the most popular thing to say was this is the year that POCs are going to move into production, and everyone is an echo chamber of this. And I was like, what are we talking about? I'm not seeing it. Maybe there's a couple instances of it, but I almost would flip that around and say, there is so much being worked on that's not in production yet, but that's coming. So that's trend number one. Trend number two is that agents are coming. By and large, the performance is still subpar, deeply subpar, but they are improving very fast. The amount of inference that's going to be required to support agentic architectures is unimaginably large. And so I'm foot stomping a couple of these points where I think de-emphasize large training runs and huge compute infrastructure required for large training runs, and that the demand for inference is going to explode, especially as agentic architectures move in. So the last 2 years, everything's been RAG-based. You push it through us or something similar, you index it in a vector database, you use LangChain to orchestrate between an LLM and the vector DB, and you prototype, right? And that stack has been maturing. You have GraphRag now, and Rohit and others on making structured data available to these architectures. We're figuring that out. But what's also happening now is that agents are able to spin up their own vector DBs. They're able to spin up their own RAG architectures. If you look at companies like Neon, these small database providers, and the number of ephemeral vector DBs that are being spun up autonomously by agents, it's just it's going like this. And so I think that's a leading indicator on the demand for inference as we figure out how to make this stuff work and move them into production in 2025 and 2026.
Brian, just to contextualize that for everyone, when a user makes a request to ChatGPT, you have one request for inference. What do you think will be the number of requests that happen for a typical agentic kind of task?
30 to 100. That's what I'm saying. Let me just, sorry, not to go too deep on this, but just spend 30 seconds on this. Suppose I type in, hey, how's Cassie, my sales lead, what's Cassie's team been up to in the last week, right? That may go to a planning agent that might reach out to an unstructured agent, right, which is an LLM, which operates our connectors to go to maybe 6 or 10 different systems of record, grab data, pull it through our API, which might each use dozens of different model kind of combinations in order to deliver that back to an LLM, and then additional inference is required to get it back to the context window to give it back to the planning agent, right? That's just it's going to be an exponential increase in the amount of inference that is going to be required in order to enable these systems.
And this is actually per request, by the way, that when you actually apply a chain of thought mixture of expert, you pick your architectural pattern. I think this is a strange time where the hardware component stack and the software component stack both are moving equally fast. This is unbelievable. Either you would have stability on the hardware and then you would build software for that, example, multi-threading in the past, but this is just unforeseen. The rate at which the software stack is changing is as hard or as fast as the software stack. I was thinking about, how do you build reliable applications for AI, in the last few weeks, and Databricks put out an amazing paper. The question is how confusing or how ambiguous the entire operation is. When you say, you log into your system, which is now AI enabled, imagine this world, you're saying, what should I be focused on? The answer to that is that, who are you? And if I don't understand who you are and what your job entails, how am I going to assist you? And so at a practical user standpoint where somebody ends up delivering value to the customer, it has to be in the context of the person who is actually there, which means that the inferences that Pierre will do versus what Rohit will do, they'll be very different, and these will have their own chain of thoughts and mixture of experts to sort of call out. And these applications are hard today to put together.
What you describe always scares me a bit, and I always think about this world where I'm going to use AI to write research, which I kind of like, but then I think that but my clients are going to use AI to read my research, and then I'm not too sure where we go, basically. Let's move to the next topic, which is what is this infrastructure going to be made of? And the question, if I simplify it, is: are we going to keep rolling out all these GPUs, or are they going to be replaced by ASICs? And of course, Keith is trying to broke like an idea that there would be a middle ground, maybe that could be AMD. But so that's my question, and I think I would like to start with Jamie. You're rolling out a lot of GPUs today. You have a lot of clients, so you have like a prime experience of how people react to the opportunity today, because the opportunity exists with Google.
Yeah. I think we're definitely long on having general purpose platforms for this, as opposed to custom ASICs that get highly tuned to sort of one technique, one model architecture, et cetera. As it is early days, we think that this is evolving very quickly, and the architectures we have today may not be there in a month or a year or 3 years. And so having the infrastructure be able to be adaptable to that, we think is critical. We invest a lot today in NVIDIA's architectures. We have tens of thousands of NVIDIA Blackwell chips coming online and available for GPU training clusters, inference services, and everything in between. And we regularly evaluate other custom silicon like ASICs, but have not yet seen, even with kind of a current model, give better cost performance. And it then prevents you from moving to new things. For example, when DeepSeek came out, we were running the full R1 model in 24 hours on our platform. Platforms that custom ASICs, in many cases like Grok, for example, are still not running that model. They're running a distilled llama version of the model as opposed to the real model. So we think being able to move quickly to new things, being ready for new model architectures like we do research on Mamba and Hyena, and there's recent work on moving beyond transformers in other ways. We think all of that is important to keep flexible for.
Yeah, I think there are some examples in the press on the enterprise side of some large enterprise customers or hyperscalers that are investing in ASICs. But if you look across the world, and I have visibility to almost every sovereign AI program in the world, so let's just say there's 30 or so sort of programs underway from Japan to Canada. I can only think of one that has leaned into a partnership with ASICs. It's almost exclusively GPUs across the world, and that's in the tens of billions of dollars. So I think that is the general. As Jamie was saying, nobody knows. Look, I was at NVIDIA when ChatGPT came out, and of course NVIDIA was early. I mean, NVIDIA handed the first GPU to Sam back in 2016, so it's not like we didn't know it was happening, but nobody knew it was going to happen the way that it happened when it came out, right? I mean, even NVIDIA was caught off guard and clicked in very quickly, but it was not foreseen, right? And so there's just going to be a lot of these things that are going to happen on a regular, just like DeepSeek wasn't foreseen. So I think general purpose computing is going to remain the gold standard. There'll be innovation at the margins, and there will be examples of other computing platforms. I do believe silicon diversity is the right answer for the world. Multiple chips in multiple clouds, powering many models. That is the definition of a resilient global economy. And there's not a country in the world that doesn't want that kind of model. But it's still very much going to be, I think, GPU heavy.
I think it's also related to use cases. I'm seeing a lot of excitement in some of our largest telco customers to move part of their analytical compute onto GPUs. And these are some of the experiments which are very, very early at this point in time. But it won't be a surprise if we see a heterogeneous, CPU stack or an XPU stack, as you call it. Everybody is trying to gain efficiencies out of GPUs which are coming in, but GPUs are not for all kinds of workloads. There are specific workloads under which they perform really well, because at the end of the day, we are talking about a compression algorithm which essentially is represented by the neural network, And sometimes GPUs will perform way better than ASICs. And people will just have to consider that heterogeneity in terms of what they need.
Brian, on your side, ASICs might be still a bit remote, but you experience this hybrid environment between CPUs and GPUs as well.
Yeah, we're seeing like a big push from, especially on the ROI kind of question here. It's like, how do we utilize what we already have with the cost of compute plummeting? We've been doing lots of interesting work on how do we optimize newer models for older hardware, for example. So for example, like A100s, CPU enabled. And then also, just to come back to an earlier point, this is in the last quarter or so, but a really interesting push from hardware manufacturers to start pushing this technology to the edge. And I think that's like taking IoT data, taking various sensor data, and being able to make that available to models, but being able to do this on edge devices. I think that is something that we're still extremely early on, and that's going to push out, I think, towards like really a broader distribution of compute requirements for it than just GPU, which I think it's been a bit lopsided to date on. So we'll see. I mean, a lot of the compute right now is from these chain of thought models that are just incredibly compute intensive for inference. But as like, for example, like we're not talking a lot about Hugging Face these days, but like there's a lot of incredible models that are available in open source on Hugging Face, on Together, on others. And I think that explosion is going to continue and then unlock new possibilities on different types of consumption patterns.
And Keith, maybe a last one for you on this topic. When you look at the angst of these very large players to deploy their own ASICs in their data centers instead of mostly today NVIDIA GPU, there is this hope of being more efficient, but there is also an angst not to be tied to a single supplier. So how do you guys see the role of AMD, helping the market being more diverse and offering alternatives?
It's an easy question because there isn't a country in the world or really a significant company that wants to be locked into a single vendor, for mission critical systems. I mean, we don't have to look any further than the very dramatic sort of system failure, early last year with the cybersecurity failure that ended up taking down a third of our airlines, one system is not the way to go. And so, actually, what's interesting is that for the first time, very recently, Canada and India were the first two to make it public, but there's at least 3 or 4 other countries that are doing it unofficially. They are demanding that investments from the government side go into at least 2 platforms, and and again, it's just a natural evolution of the space, right? I mean, there isn't a single Fortune 500 company that puts all of their data in one public cloud. It doesn't make any sense, right? That's the definition of a single point of failure. From a business continuity perspective, from a resilience perspective, but also from a TCO perspective, right? I mean, you want to have the ability to negotiate, you want the ability to capture all the innovation, and every company, no one company has all the innovations in the world. So you want to capture all of that. So we just see that trend as a very easy conversation. All the countries, all the companies are leaning into NVIDIA and AMD as their 2 primary providers. It takes years to play out. You're talking about significant investments, but you're also, just to put it in perspective, because just again, from a global perspective, all of the world's supercomputers, I mean, literally all of them sit in 34 countries. That's it. You have 190 something countries in the world, and 160 of them do not have a GPU. Okay, so the market is still very, very early. And that's a whole nother conversation in terms of global equity and so forth. But the majority of the computing sits in 34 countries. And of course, within that 34, most of that computing sits in probably 6 or 7. So the vast majority of the world has still not built out their AI infrastructure. There's literally no computing, in a lot of smaller countries. So there's a lot of time for innovation, and there's a lot of time for new companies and for new models and new growth and new chips. And so we are in the very early stages of building out this market.
Thanks. We have 5 minutes left, so what I'd like to do is actually a lightning round around the last theme I had on my agenda, which is the digital goods. So maybe if you could each tell us first how you see that happening, like AI becoming suprahuman on a significant number of tasks, When and how do you see that happening? And how is that affecting your business? And when I'm asking you how it's affecting your business, think about it as, of course, your addressable market, your opportunity, but also your own operations. How is it going to change the way you run your own business? Brian, do you want to start?
Oh, I don't want to be picked first. Jamie, I think you have a lot of thoughts on this. You want to go first, Vin?
I think Pierre said I had to go last.
Oh, is that right? Look, I think from a development standpoint, I think that what we've learned over the last couple of years is that we can't really predict anything. Some things have moved a lot faster than we thought. Some things have moved more slowly than we thought. I think that what we'll see is like in the next. I think it's going to take 2 to 3 years to see significant penetration and like overhauling like actual like workflows within companies, within organizations to drive ROI. I think that's going to come more slowly than we think, but then we're going to see these big leaps forward. I think like what we'll be looking for on our side is earnings call transcripts and folks actually showing ROI on this. Like that's where the rubber hits the road, and it's been very uneven to say the least so far. But I'm incredibly optimistic given a lot of these trends that we've talked about today.
Yeah. I think I would say I'm a technologist. I'm not a sociologist or an economist. And micro example is Brian was saying that the gap between what's happening with these foundation models at the frontier is just like incredible progress, and the adoption in certain different business applications is lagging and taking longer. And there was the year of POCs, and so I think 2 years ago I probably would have felt like the technology was not going to get there anytime soon. Today, I feel quite confident the technology is going to be getting there very, very soon, much faster than I would have expected, and I think anyone else. And that'll happen not only for it'll happen really fast for digital tasks. Technology will be capable of doing like 90% of digital tasks better than 90% of humans on those digital tasks. But it'll also happen for physical tasks. Robotics is the next huge wave happening that is going to be seeing similar gains. And then I have no idea what that means. I don't know what that happens to society. I don't know how long that changes how much people work. I don't know what that does to the economies or anything else. As a technologist, I can only speak to what I think that will happen with the capability, and then who knows for adoption.
There's all these benchmarks, and every 3 minutes someone rolls out a new model they say is better than the one that came out 3 minutes earlier, and on benchmarks I don't understand, and benchmarks that someone else created. And I think it's a bit of nonsense personally. I think actually the models are really good right now. I'm sure they'll be better tomorrow and amazing 6 months from now and those kinds of things. But I actually think the capabilities even today are incredible. And I see them just even my own family with my older children, one who's 22 and he's an AI architect, and he's one person and he can generate millions of lines of code a month because he's using all the different tools that are available to him now. He does very little coding now. He does more architecture, but he has the AI, he's doing all the coding, and he's incredible. He's like an army, just one person. And it's just incredible to see that. And then I see my daughter, who's a sophomore in college, and she uses the LLMs to help her think through outlines for work. She works at a think tank. She uses it to help her summarize documents and things. And it's just like for that generation, that's just their life. It's not that interesting. It's not transformational. They're going to go into the workforce fully equipped, fully literate, fully using these tools, and they won't know anything else. And so I don't know how long that's going to play out either, but while we sit here in hotels and debate when it's coming, I see it already. And of course, I see it at AMD too. I see all the customers, and I see the startups, and I see the hyperscalers and what they're doing. So I think it's just this information is a little unevenly distributed. People want earnings. People want big wins. These things take time, but I feel like it's already happening pretty intensely, and I don't think it's a futuristic conversation.
Yeah, and I'll just add perspective from my own company standpoint. We are not going to add developers this year. We are not going to add folks in marketing this year. And all our AEs will be self-enabled using either Perplexity or ChatGPT. When I started my career about 20 years ago, so much of it was about writing a lot of code, writing a lot of boilerplate. I can assure you that what Keith was referring to is absolutely accurate. I won't be surprised if last year we generated over 1 million lines of code and checked it into production, and that code is right now running. So the generative part of this whole generative AI movement is absolutely true. It is doing a lot of work for us, and it will make all companies more efficient. I hope, and I agree with Jamie that none of us here are economists or sociological analysts or societal analysts, I would say. So can't comment on that, but all teams will be way more efficient in the next couple of years, hugely efficient.
I think we're coming to the end of our session. So Brian, Jamie, Keith, Rohit, thanks a lot for making the time.
Thank you. Thank you.